In the following video, my team and I will show you how to draw and also name all the structural formulas for all the different types of hydrocarbons. First, the UPAC, also which means the International Union of Pure and Applied Chemistry, which is an international organization that is also independent. This organization works for chemistry to advance in all global standards. It is very important, this UPAC rules, because they define all the different types of hydrocarbons. We can know which hydrocarbon we're looking for because of their characteristics and rules.
Well, hydrocarbons are organic compounds that are formed of carbon and hydrogen atoms, and they are usually found in the natural gas and the crude oil, for example. They have different classifications, and that is according to their different bonds. For example, alkanes are the ones that contain carbon-carbon single bonds. Alkenes are the ones that contain carbon-carbon single double bonds. Alkynes are the ones that contain a single triple bond. And last, aromatics are the ones that contain benzene rings and their derivatives. So hydrocarbon derivatives are molecular compounds that are made of carbon and that contain at least one element that is not hydrogen.
The next step is to number each carbon in the parent chain. Locate the end carbon closest to a substituent group. Give all the substituent groups the lowest position numbers possible. So you have to count like this. 1, 2, 3. Here is something. 1, 2, 3, 4. So this one was the closest. So you're gonna count 1, 2, 3, 4, 5, 6, 7, 8. And you have to write it on the chain. The next step is to name each alkyl group substituent. Place the name of the group before the name of the parent chain. The fourth step, if the same alkyl group occurs more than once as a branch on the parent structure, use a prefix. They are D, 3, tetra, and so on, before its name to indicate how many times it appears. Then use the number of the carbon to which each is attached to indicate its position. When different alkyl groups are attached to the same parent structure, place their names in alphabetical order. So this is step number 5, tells you to not consider the prefixes D, 3, and so on when determining the alphabetical order. And the step number 6 is write the entire name, using hyphens to separate numbers from words and commas to separate numbers. And that's it in the alkane naming. We will do one exercise with this example. Okay, the first rule is count the number of carbon atoms in the longest continuous chain, the parent chain of the structure. Having this, we have this chain, or this chain, or this chain, or this chain. But we have to choose the longest. So it will be this one. See, there are 1, 2, 3, 4, 5, 6, 7, 8. That's the longest possible chain.
To draw alkanes, we start with the most basic one, which is methane. Meth means 1, so it's only containing one carbon, linked to 4 hydrogens and 4. Remember that's methane, and the formula would be 1 carbon, hydrogen 1, 2, 3, and 4. Methane, it's an alkane. Now the next one is a little bit more complex, but we can see that it's an hexane. So it's 6 carbons. We'll draw 1, 2, 3, 4, 5, and 6. Rules to name alkanes. The first step is to count the number of carbon atoms in the longest continuous chain. This is the parent chain of the structure. Step 2. Number each carbon in the parent chain. Locate the end carbon closest to the substituent group and give all the substituent groups the lowest position numbers possible. Name each alkyl group substituent. Place the name of the group before the name of the parent chain. Step 4. If the same alkyl group occurs more than once as a branch on the parent structure, use a prefix D, tri, tetra, and so on before its name and indicate how many times it appears. Then, use the number of the carbon to which each is attached to indicate its position. Step 5. When different alkyl groups are attached to the same parent structure, place their names in alphabetical order without considering their prefixes. And finally, step 6 is to write the entire name using hyphens to separate numbers from words and commas to separate numbers. Now this one is a little bit easier. We have a penthane, so we have 5 carbons, 1, 2, 3, 4, and 5. And we have a methyl in carbons 2, 3, and 4. So we place them. Is CH3, CH3, and CH3. And in the rest, we only place the hydrogens that are missing. CH3. Only 1 because we already have here 3. And we place the bonds, and that's it.